Hey everybody, and welcome to the Multi-tenancy Working Group, our last official meeting of 2019. Today we have the Ryan of Cray Computers, and he's going to give us a run through of CoreDNS. So Ryan, take it away.
Sure, I need to figure out how to share my screen. Do I have access? Oh, that's the big green button. So this is on at KubeCon, they kind of announced, or at least I heard that they had created a generic firewall plugin for CoreDNS, and with that, they allowed you to use an external policy engine to make the decisions for the firewall plugin on CoreDNS. And so I had promised last week that I would attempt to do a POC for this, and here I am. So this is pretty simple. What we're going to do is kind of show how we can allow, refuse, block, or drop a DNS query in CoreDNS based off a decision that OPA makes. I'm going to assume you have some sort of knowledge of CoreDNS and how DNS works, as well as some knowledge on OPA, but we'll get into the particulars a little bit. And then we'll demo it, and then I'll go over some of the gotchas that I ran into when I was deploying this. As I mentioned before, I literally did this morning because I kind of forgot about it. So it's a little rough, but it does work, and it should be pretty easy to kind of polish up. So the first thing I'm going to kind of go over is the actual OPA policy that we will create. This is basically straight from their GitHub example. If you know Rego, it kind of looks pretty straightforward. If not, you'll pick it up pretty quickly. And they have an awesome playground here where you can actually put in your policies on their website, and then you can pass it in inputs and then determine what's out there. So we'll do a demo of this in a second, but first we'll walk through the policy. So first we're just basically going to grab from the incoming request the name, which is going to be the actual DNS name we're looking up, and then the client IP, so the requester of who is actually requesting that name lookup. And then we'll have a default action of allow, and then we have kind of this weird kind of for kind of switch thing that kind of indicates of what the action variable will be set to based off of what was called below. And so we'll see, so it'll be, there's allow, refuse, block, and drop, and these all translate to actual DNS responses. And so we'll kind of see that in later, but you can kind of guess a refuse is actually saying, I refuse to actually answer this. Block would basically just return an NX domain to say, I don't really know what it is. And then a drop essentially just gives up, and then eventually the client will retry a couple of times and then it'll time out. So that's basically what will happen from a DNS perspective. And so you'll see here, we'll take a couple of just domains. So we'll block github.com, we'll refuse kubernetes.io, and we'll drop google.com. This is what I call developing in hard mode. And then you'll see here we can go even further, and this is from their examples. We can allow anything, so we can have all this stuff, but then we can allow anything to go through if it's part of this CIDR block. So if the incoming client IP is part of this, we will ignore the above. And what will actually happen here is it's going to go through all of these, and so you can have multiple matches that will get responded back. So there is a possibility that if you're part of this CIDR block here, it will actually return in the payload from OPA. The action will be set to allow, but then it'll actually have block equals true as well as allow equals true. So you can do more complex things. The CoreDNS plugin itself just cares about the actual underlying action. And we'll get into that. But so there's the Rego policy. Before we actually demo it here, is there any questions on Rego and how this works? Awesome. Okay, so right here with the awesome Rego playground, we'll see that we'll pass in a request that will look pretty similar to what CoreDNS will send to OPA. There'll be a bunch more stuff. It'll actually send metadata. You can actually have it register and send metadata, and you can do grouping stuff and get pretty advanced with this, but I'm keeping this pretty basic. So if we do a request for google.com and our client IP is this, which is not part of the CIDR block below, you'll see that we'll get an action equals drop, and then drop equals true. So this is what will be returned back to CoreDNS or the CoreDNS plugin. If we change the CIDR to match, we'll actually give an allow. And as I mentioned before, both of these variables will return as true. But CoreDNS really only cares about the action variable. And this is really just kind of omitted at the plugin level. And then if we go through anything else, right? So if we do Cray.com, the allow is true and everything else because it doesn't actually match our things. And then if we do GitHub, you'll see that we'll have a block as well. And then I think I already did that. And then Google will be drop. And then Kubernetes will have the, well, I hope it's been spelled correctly. We'll have the refuse. And since we're started as part of the CIDR block, it always allows, but you can see that it's picked up. If we change that CIDR block again, you see that it actually changes the action. And that's a pretty simple Rego policy and how it works and how this works in the context of the CoreDNS plugin. It's pretty straightforward. Their docs go into a little more detail of some more advanced things you could do. So this is kind of the OPA setup, and basically what we're going to deploy is we're going to deploy OPA with this basic policy and have CoreDNS send all name lookups to it. Any questions on the OPA side? Awesome. Cool. So then the next thing we're going to have is we're going to have our core file for DNS, and this is pretty simple as well. We have the plugins, as I mentioned. There's the generic firewall plugin that's new, and that basically says for firewall at the query level. So you can do requery, the query, and I forget what the actual keyword is, but it's the response. So after it does the lookup, it can send it to OPA as well instead of before. And then we're just going to basically send it to OPA called my engine, which is up here, and then that just is telling it to go to localhost. At this, and so this is basically just OPA running locally. We're gonna run this as a sidecar. V1 data, and then DNS is the name of the package of our Rego policy, and so that's what dictates the URL there. And then action is what is the lookup or the response that we care about, and that's where that comes from. And so that's pretty straightforward. One of the gotchas that is part of this is because we're running OPA as a sidecar with CoreDNS, CoreDNS's default readiness probe is on port 8181, which is actually conflicts with OPA. So in our core file, we actually changed the readiness probe port to 8081 to remove that conflict. And then in the readiness probe below, we in the actual config, we have to make sure we change that as well. So they match. And so that's a gotcha that we had. From there, it's pretty straightforward. We're just going to create a service that is UDP and TCP on port 53 for DNS. And then, as I mentioned before, we're going to deploy CoreDNS and OPA as a sidecar to it in the same deployment. We're mounting our policy as a config map and passing it in. Same with our core file, pretty straightforward from that perspective. And then that's kind of about it from a deployment perspective. The other gotcha that I've kind of glossed over here is that I actually have to use my own CoreDNS Docker image. And the problem with that is CoreDNS plugins, they are a compile time, they're loaded at compile time. So we actually had to enable these new third-party external plugins. Even though they come from CoreDNS, they're still technically external because they're still relatively alpha beta. And so I had to build that. And it's actually pretty trivial how to do that, and I'll talk about that in a second. But yeah, so once we deploy this, it will get deployed and then we can test it out. Any questions on the actual YAML and how we're deploying CoreDNS and OPA, et cetera? Cool. Wow, this is going great. So as I mentioned before, we had to compile.
Hey, Ryan,
Yeah.
I have a question.
Sure.
So you're deploying this as a sidecar. What if how does this work then if I have a service mesh and it has a sidecar? Who intercepts the traffic, or how does that get routed? You know, because if I have a sidecar and a mesh and I always come through that proxy, does it still, just curious, what's that interaction?
Sure. So, yeah, if you have a service mesh, I mean, it really depends. If you're doing a service, if you're actually injecting the service mesh sidecar to your DNS, that would, regardless if you're doing that or if you are doing, if it's just on the actual end services, the proxy is all it's going to do is it's going to basically generally, and I'm talking about Istio because that's what I know better than the other service meshes. But from an Istio perspective, right? All it does is it hijacks the incoming and egress calls to the service mesh or to the actual service itself. So let's say we have just like an Nginx server that's running and it has the Istio sidecar. Any request into that will be sent to the Envoy proxy for Istio first, and it will do its processing, and then it passes it through, and then the egress will then go through the filtering. So depending on how your filtering is set up, it shouldn't really matter, because what's going to happen is, well, for one, Istio doesn't really handle any UDP traffic. So assuming you're using UDP for a DNS, it's not going to matter. But regardless if it's over TCP, it's still going to make it to our CoreDNS pod eventually. So it's going to get into the pod and run through this lookup. And so from this perspective, because this is a sidecar, it's on localhost, and communication between localhost, even in it, at least the Istio service mesh, my understanding is it's not actually going to re-go through that Envoy filter. So the CoreDNS to the OPA communication will be skipping the Envoy proxy, assuming it would be there. Does that make sense? That was
Yeah.
kind of
Okay. Thanks.
Sure. So yeah. So that's the setup. The gotcha to creating your own CoreDNS container, as I mentioned before, it's not too difficult. So all you have to do is clone the CoreDNS repo itself. And in there, they have a plugin.config. And they actually have some nice docs here of what you have to do. Essentially, you just have to do go generate after you edit this file, and then you follow their release process. But all I had to do here was add the firewall and OPA plugins, and then fully qualified links to the plugins in GitHub here. And then after I do that, I do a go generate, and it basically regenerates, and then you call their make file, and I think the README itself has it all in here. I forget which README it was, but there's a README for, yeah. In the release, maybe it's in the actual firewall README, but it gives steps. It's basically you do make release, and you pass it in the Linux architecture that you want, or defaults all of them, and the repo. And then basically what it does is you do the make release and build the Docker image, and you push it up, and it compiles it with those plugins, and then it's there. It's pretty trivial. I think they intend to eventually have these built in, but I'm not quite sure of the time frame for that. And yeah, and so after we build that and push it up, we have it there. Let me check my other list of gotchas. Yes, the other gotcha too that I noticed when we're in our core file, the decision for a refuse or a drop or a block will basically be omitted if you turn a forwarding on, because it then it says, oh, I don't know how to handle this locally, so I'm going to forward it on, and then if it has an answer, then it actually returns. I'm not quite sure what the intent of that is, but basically, so it seems the limitation of this is largely based around if you're the authority for a specific zone and validating for that, which will work really well within Kubernetes itself if you're trying to block multiple different services or different namespaces or different tenants. That could be leveraged pretty quickly because you actually are the authority of that zone. But in our example with like GitHub and Kubernetes.io, that kind of starts to break down when you forward your request off to get the actual IP. Yeah, and then that's kind of about it for the overview and the setup. Now we'll actually go into the demo. Any other questions before we get to the demo?
So, Ryan, why do we need that firewall plugin?
The firewall plugin. So the firewall plugin is the CoreDNS plugin for allowing you to refuse, block, drop, or allow DNS lookups based off of some sort of query or some sort of parameters. And so that is the plugin that allows you to pass it to OPA. So if we do the CoreDNS policy is the actual plugin structure. So this implements the firewall as well as CoreDNS, and then a couple others. Themis is the other one for policy. But basically, you don't have to use OPA with the firewall plugin. You can do any sort of kind of like a regex type of query. So you can say all of this pretty hard coded in the actual core file itself. So if your rules for what you're going to allow and disallow is pretty static, you can build it in without piping it up to OPA. The advantage that OPA gives you and pushing it out to OPA to make that decision is you can quickly iterate on your Rego policies and have those propagate out and change them based off of external factors, and then update them, and then OPA can change its decision policies based off of that, and instead of having to basically reload your core file and updating that. That's I guess the difference. Does that make sense?
Okay, yes, thank you.
Ryan, I have a quick question as well.
Sure.
Let me know if the demo will cover this, but I'm not sure how I understand this working, like what kind of multi-tenancy use cases is going to address. Is it the case where you have multiple completely independent users of the same cluster who don't even share the same DNS service?
Potentially. So I don't really know the full application. I just thought it could be pretty useful for some people. But one use case could potentially be you will either you basically want to disallow any DNS lookups to a different namespace if they are not part of a group. So you can, as I mentioned before, you can do metadata in the firewall. Let's see if I think it's in the actual OPA README. So you could do metadata for, they have too many readmes. So right here, so you can do metadata in the actual DNS request. So if there is metadata added to the DNS lookup, you can refuse based off of that. So if the dig call or the DNS lookup had some metadata for a tenant built into it, we could then and that was signed. So you can, with modern DNS, you can actually sign the request coming through. We can basically allow lookups for different services running in different namespaces to prevent just kind of walking. Oh, is this an actual pod, and can I query it on these ports? Just kind of more of a scanning perspective. Is I guess one lookup or one kind of use case I can think of. But yeah, I don't know of any concrete use cases for.
Today, by default, either with or without RBAC, can you look up DNS entries in other namespaces?
Yeah, so the default for Kubernetes is you can look up any DNS entry in the cluster that's kind of generated. In my understanding too, network policies don't prevent the DNS lookup itself. You just won't be able to access that range. So the DNS will still resolve. You just won't have access to that system. So this kind of helps prevent some metadata leakage to figure out what services other teams may be running in the cluster, and then use that metadata to maybe find potential leaks. Like if you find out they're using MongoDB, you could be like, oh, I know the ports for that, and I know some exploits, and then potentially try to get around it. That could prevent some of this from a security perspective. I'm not saying this is the end all be all. I just thought it was pretty interesting and potentially something we could leverage in the future.
So,
So CoreDNS by itself is not planning on adding any feature which scopes DNS responses to the originating namespace. That'll always, so because you can't prevent it with RBAC either, right? So there is no RBAC way to scope DNS queries to their own namespace. So CoreDNS itself planning, a way of having a config option to limit queries and responses within the same namespace?
That's a good question. So that would fall under the Kubernetes plugin, which is built in to CoreDNS itself here. And so their README kind of gives the possibilities of how you can leverage that, but I'm unaware of any work being done there, but I'm also not an expert on CoreDNS either. It would be useful for us to, I guess, reach out to the CoreDNS folks to see what their thoughts are, the people that kind of own this plugin. But it's, from a DNS perspective, it's kind of difficult to limit that from an RBAC perspective, just because then I guess, where do you draw the line? You know what I mean? Is it, if you don't have DNS outside of your namespace at all, then how do you ever talk to anyone outside of your namespace? Especially, like, how do you talk to the API server and the system namespace, etc. So
I was saying, for the case where it's in another namespace, it is on cluster.local, but it is on another namespace.cluster.local. Anyway, that's fine. RBAC is anyway in the API server, and we're talking about a data plane event here, so it's not matching RBAC anyway.
Right. And so, I mean, everything is, it's cluster.local, and it's going to be the service or pod name dot the namespace dot, service.cluster.local. So it's kind of well defined, and so you could potentially lock it down from that perspective. But I'm unaware of any work being done in the Kubernetes perspective to make that easier in Kubernetes. Okay. And I think the answer would likely be this plugin would be the solution to that.
Hey Ryan, there is a security perspective query coming to my mind. Like, imagine we have a tenant, and that tenant or the pods are compromised, and there is a DOS or DDoS attack towards the core DNS from that tenant. So can OPA help us in securing the the core DNS?
To protect from a DDoS attack, not from this perspective, I don't think. I mean, it would basically, you would probably want to prevent against that elsewhere. But at the same time, if it's UDP traffic, and DNS is generally really quick, it kind of takes a lot to take it down, and we can always scale it if we have to. But if we're talking to the point of full DDoS, then we would want to use something else, and you could use circuit breakers or other load balancers if you're truly concerned about that. But I mean, DNS is generally kind of fundamental to most things, and so you have to be pretty resilient and be able to handle significant amount of load generally. So I guess DDoS is certainly happens, but it's, I guess, one of my lower concerns. But
okay.
But I don't see. But from that perspective, I don't really see this plugin helping with any of that. No.
Okay.
So Ryan, on the point you made earlier about this working alongside with network policies, right? Because that's interesting. I was just thinking out loud, if anybody's kind of thought through, is it possible to take a network policy and just translate it to some settings on CoreDNS?
Well, so CoreDNS, right, is just the DNS lookup. So it's just going to say, here's a name, here's the IP that validates to it. And then the network policy itself would enforce the actual communication over those IPs. And so this is kind of a step in there. It can say, oh, you don't actually get an IP address that's associated. So it prevents, I guess it can help prevent against some network policy traffic if you're relying on DNS. But then if you have the IP address, you still want that network policy in place.
Sure. No, so yes, so I understand both are needed in the separation of the two, but it seems like all the information necessary to generate these firewall rules would also be described in the network policy. So perhaps if there's a way to just create these firewall rules from the network policy, that simplifies having to configure two things.
Yeah, I agree. And I think, I mean, it would be nice if, well, I mean, there's not really a good way to shell out a network policy decision based off of OPA, but yeah, it's kind of hard from that perspective to keep up. And I mean, the main problem with network policies in general is most people don't use core Kubernetes network policies, or many people do, but many people use other implementations from like Calico or Istio or others. So it'd be kind of difficult from that perspective, but it's something that potentially you could look into. Either an operator is trying to facilitate both of them, and it could potentially generate a network policy and generate the Rego to correspond at the same time, and then have those rolled out.
Jim, I'm not sure how a network policy would work for this case, because you're maybe thinking of a case where you apply a network policy to the core DNS pod, and which says, match if the source is from this namespace, then the DNS response, which is inside the packet, has constraints, right? So
well, I think it's more so, right, if we have a DNS entry and we want to refuse traffic from like namespace A to namespace B, sure, this core DNS will say, oh, I'm not going to give you the IP address of it. But if you actually come across that IP address, or you just walk in, IP ranges, you could eventually hit a pod. And so if you don't have a network policy there to prevent that traffic as well, then, you're still in. So this is more so a layer above. Yeah, if you're using DNS, we won't allow it, but the network policy is at a lower level.
Okay, so essentially extrapolating from the network policy to also derive a DNS filtering policy.
Exactly. So to just use that as the firewall rule, either directly in CoreDNS or through the OPA or some other policy plugin.
Mm-hmm.
Yeah, that would be interesting, especially since like if you've looked at the external DNS CoreDNS plugin that can use annotations to basically add DNS entries to CoreDNS, I think some sort of tie-in with that could be beneficial. Of it could read that and then do your CoreDNS Rego policies, as well as potentially some network policies. So I don't know of anything out there that exists, but I definitely think it'd be kind of cool if you could make something like that. Sounds like a break project for someone. Any volunteers? Cool. Anything else before we do a quick demo? Awesome. So I have some terminals up now. Can you read this okay, or do I need to make it a little bigger?
Bigger would be nice.
All right. So let's see. So on the bottom here, I'm just tailing the logs of our OPA sidecar. So I'll do real quick. So I just have a GKA cluster up, and I have the OPA DNS namespace, which has applied the YAML that we went over previously. You can see we have a single core DNS pod running with two, our core DNS pod, as well as our OPA pod. And so below here is the OPA pod, tailing those logs. The DNS logs aren't really that useful, and this kind of gives us what we need. And so then I'm just going to open up a shell to a container that's running in the cluster, just in the default namespace, just so we can basically have this. So this is DNS running outside of Kubernetes, and it's not actually, nothing is actually pointing to it. This is just kind of to demo it. And so we'll make some direct dig calls to it. So the first one we'll do is we'll do a dig call to kubernetes.io. And as you may remember from our Rego policy, we told that to be refused. You see what you might have saw in the logs, it blipped really quick. And you can see here, we had a request come in on a client IP. And then the actual response will be in here, response body at the bottom here, refuse. And so OPA got the request, it decided to refuse, and you can see here in our dig call, we actually got it refused back from the call. So if we go up again and we do Google, Google, if you remember, this is the one that was dropped. And so you'll see in OPA, we'll see a couple of requests go through, and OPA is telling CoreDNS to drop it, which means it doesn't actually respond. And so our client, our dig command is going to retry a couple of times, and eventually it's going to time out. And so this is basically kind of like saying, hey, I don't know whatever to do, and it just, timed out. And then the last one we have is GitHub, and again, this is a block, and so the block is basically do an NX domain as, and I don't really know what to do with this, and it doesn't have any authority, and it just returns, and that's basically about it. All the other ones, right now, as I mentioned, since I'm not forwarding anything on, nothing else is really going to work here. We'll get probably an NX domain on all of them, or sorry, a serve fail because it can't actually doesn't know what to look up. But yeah, so that's kind of it. So assuming we had authority on these domains, we'd actually get an actual IP address for any of the non ones. But so that's kind of dependent on your DNS structure and what you have set up and how you plan to do that. But if you're an authoritative on a zone, and then you do these OPA policies, you can kind of validate that. One of the things that I would really think would be nice, and this is more selfish for how we kind of implement things, is we have many different networks, and so we have different IP ranges, and so it would be helpful if we could actually use this as a way to determine the IP address to resolve with this based off of the same name. There's other ways to do that with transfers and all this other stuff, but this would be kind of, I think would be helpful. And that's kind of what we're planning to use it for, is to help validate CIDR ranges for requests to make sure that the response queries match the actual ranges in the network. Yeah, so that's kind of what we are planning to use this for eventually, but it's still pretty new. If we look at the actual policy, I don't think it's been even released. I think it was released like a week before. Yeah, they don't even actually have an official release. I think it was released like a week before KubeCon. So it's, the initial commit was only, 5 or so months ago. So it's still new, but it works pretty well. And it wasn't too difficult to get it running. The most difficult part was, having to create your own CoreDNS Docker container, which is not ideal, but once that's done, it's pretty simple. And then the big advantage here is, you can have your Rego policies updated kind of out of band and based off of other use cases, and then those get propagated through, and DNS doesn't need to be restarted or clearing any caches or anything like that in order to make those decisions. And that's kind of all I had. Any other questions, or did I miss any of my gotchas? And then, yeah, so as I mentioned, you can use OPA bundles, which is their kind of service to generate these on the fly instead of using a config map. That's obviously the preferred method of using OPA, but this is mainly just for demo. But
so Ryan, any thoughts in terms of latency and lookup delays that this could potentially add?
I mean, definitely there's going to be some, right? And that's one of the reasons why it's recommended to kind of, in general, if latency is an issue, to run OPA as close to the pod or the actual workload running. And that's why we did sorry, I was looking at chat. And that's why we did a sidecar, so that they're in the same pod. And so if we scale out our deployment, each of those CoreDNS pods will have their own OPA that they can talk to, and it'll be on localhost and very close. So there'll definitely be some latency for sure, especially compared to traditional DNS. But as as the industry kind of transitions to DNS over TLS and using TCP, we're going to start seeing, more, I think, advancements in the caching and the optimization layers there. That I think that this might be worth it. And I don't think this is going to be something that everyone will use fully, but I think it could be a tool that could be beneficial for some certain, use cases in Kubernetes or elsewhere. And yes, the question in chat was, are you going to publish this? Sure. Yeah, I can push this up to GitHub quick and unpublish it. I'll polish it up over break and push it up there and post it to Slack. Any other questions?
Thanks, Ryan.
Cool. Sure.
Thank you, Ryan. Nice presentation.
Yeah, thank you.